In 2017, the security firm Trail of Bits published 11 examples of vulnerable Solidity code on GitHub. A teaching repo, named Not So Smart Contracts. 8 years later, a database of over 90 million analyzed EVM contracts runs in production under exactly the same name. That's not a coincidence. This is a story about lineage, how Web3 security gets built on top of what came before, and what it still needs to become a public good. Let's be precise, because the two shouldn't be confused. Trail of Bits Not So Smart Contracts is an educational resource. 11 vulnerability patterns, reentrancy, bad randomness, integer overflow, each rooted in a real exploit. Ninja's Not So Smart Contracts is a production database. 90 million bytecode records, function selector mappings, vector embeddings. Different use cases, different scale. The name is a tribute, a way of saying that without them, today's DeFi security wouldn't exist. 90 million sits on top of 11 examples. The 90 million database means something because of what was built before it. In 2015, OpenZeppelin wrote the base infrastructure, the ERC-20 and ERC-721 reference implementations, and the contracts library most of DeFi still depends on. From 2017, Trail of Bits provided almost the entire verification tool chain. Slither, Echidna, Manticore, static analysis, fuzzing, symbolic execution. Today's DeFi audits don't work without them. And audit firms like Consensus Diligence turned professional auditing into an industry standard. The lineage kept growing. Immunefi built the bug bounty economy, over $100 million paid to white hats. SlowMist made incident tracing industry practice. Forta built decentralized threat detection. SEAL 911 runs the emergency line. Hacked projects reach experts within 24 hours. ZachXBT tracked launderers and rug pulls solo. They cite each other, share tools, publish postmortems for each other. The lineage looks scattered, but it's one woven fabric. Ninja is trying to add one more cloth, standing alongside, not above. Now compare that with Web2. In 1999, MITRE launched CV, Common Identifiers for Software Vulnerabilities. Today it holds over 250,000 entries, connected to NIST's vulnerability database, each with a severity score and patch information. On top sits CWE, the weakness classification, SQL injection, cross-site scripting use after free. Vendors request CVE IDs for their own bugs. Security teams worldwide crawl it daily. Vulnerabilities became a common language, referenced by identifier. Web3 has no equivalent yet. It's not for lack of trying. The Ethereum Foundation's Smart Contract Weakness Registry started with the same idea as CWE, and it's been frozen since 2020. There is enormous individual effort, audit reports, classification schemes, incident write-ups. But no unified registry. Trail of Bits 11 patterns should have grown into a living, numbered catalog. That never got institutionalized. Why? Because public goods don't pay anyone's salary. Economists call this the undersupply problem. Goods anyone can use are hard to fund through markets. CV exists because the US government pays MITRE roughly $15 million a year to run it as infrastructure. Web3 has nothing like that. Trail of Bits maintains its open tools out of commercial audit revenue, public goods as a byproduct. If audit orders drop, maintenance stops. Immunefi's bounties reward jackpots after the fact. Nobody pays anyone to build systematic classification in advance. So knowledge stays trapped inside individual projects. What does 90 million actually mean? The 11 examples were written for humans, a few dozen lines each, why it's vulnerable, how to fix it. The 90 million records are written for machines. Selector mappings that resolve a 4-byte selector to a method name even on unverified contracts. Vector embeddings that compare any new contract against the known set. This one is 87% similar to past exploit targets. Nobody reads 90 million records. The point is judging, in seconds, how a new deployment structurally resembles past exploits, like a contract that sits dormant for 14 days before it strikes. Education and mechanization, different stages of the same lineage. Ninja's answer to the public goods gap starts with an honest question: what stays a moat, and what opens up? The moat is 5 things: the 90 million contract database, the model weights learned from it, production infrastructure, customer contracts, and the learning loop. Everything outside those 5 is a candidate for opening. First 2 openings: a feedback interface SDK, MIT licensed, one common protocol for reporting false positives across the industry instead of every vendor's separate form, and a client SDK for wallets, dApps, and agent frameworks. The pipes open. What flows through them, and what learns from them, stays Ninja's. Next, vocabulary and knowledge. The 13-category intent taxonomy gets published as a common classification for what a transaction is trying to do, the way CWE made SQL injection a shared concept. Incident postmortems get shared, anonymized, so a pattern found once lowers the odds industry-wide. And the methodology goes to peer review, the 2-layer architecture and bytecode ML approach, submitted to venues like IEEE Security and Privacy and Usenix. Papers publish methodology, not model weights, and not training data. And connection. Ninja alerts flow into SEAL 911's emergency response. Detection integrates with Forta's bot network. Data is shared with OpenZeppelin Defender. These are trusted community infrastructure. A newcomer reaches users faster by connecting than by running alone. Finally, ERC 8004, the draft standard for an on-chain AI agent trust registry. Ninja joins the reputation and risk scoring side, because standards get made by someone, and being in the room shapes what agentic era security looks like. The honest part: 4 things stay closed. The detection logic behind the 17 alert codes, trigger conditions and thresholds, because publishing them hands attackers a manual for dodging detection. The layer 1 model weights, because with the weights, attackers can systematically craft contracts that evade classification. The raw 90 million record database, exposed through APIs but not distributed as dumps, though older snapshots may open for research once the business stands on its own. And the policy language behind Shogun's governance controls. The line is simple: methodology and structure open, individual detection logic and data protected. VirusTotal doesn't publish its rules either. Why the conviction that public goods must be built deliberately? One project from 13 years at Accenture, cross-industry fraud intelligence for the credit card industry. Issuers, brands, and acquirers each held their own fraud logs. We built 2 layers. A machine layer, where a fraud pattern detected at one company reached every other company's models within hours. And a human layer, researchers from competing firms meeting monthly to share what data alone doesn't convey. Before it, the same phishing playbook hit Company A in May, Company B in July, Company C in September. After it, response times fell from months to hours. Shared intelligence doesn't emerge naturally. Someone has to build the venue. Web3 has one structural advantage Web2 never had: the data is already public. Every transaction is on-chain. The missing pieces are shared identifiers, shared formats, and neutral operators. That's where grant funding goes: the SDKs, the taxonomy, the papers, the integrations, the standard. Commercial API revenue funds the business. Grants accelerate the public goods layer. Separate funding for separate purposes. Web2 took decades to build shared intelligence. Web3 could do it faster. Ninja sits on the extension of the trail of bits, Forta, and SEAL 911 lineage. That is what the name Not So Smart Contracts has meant since day one. If you run a DeFi protocol, a wallet, or an agent framework, ZKSC is looking for proof of concept partners. If you want to help spec the open SDKs, contributions are welcome. And you can try it now. Send any contract address to the Ninjascan bot on Telegram. Web3 security still has no CV equivalent. Unless someone builds it, the lineage keeps resetting with every incident. We want to be part of that integration.